Well, hello and good morning, or whenever you're listening to this or watching this. We're going to finish up chapter 2. We've talked about functions, linear functions, a bunch of different things, translations, and so on. We're going to talk about how to put some of these together to create what I call designer functions, if that sounds good to you. So we're going to put them together. We're going to add them together, make new functions. We'll put some inside each other. That's sort of weird, but we'll learn how to do that. And something called the difference quotient. And just so you know, the difference quotient is sneaking a tiny bit into calculus. All it is algebra, so don't worry about that. But it is sneaking into calculus. So you can tell people, hey, we did a bit of calculus today. Oh, here we go. So we're going to talk about starting with some functions. And we give functions names like f, g, h, and so on. Sometimes when we run out of those, we name them capital G, capital F, capital H. A little bit boring, and if we really have a lot of functions, then we'll go back and number them. Function 1, function 2, function 3, and so on. So what we're talking about here we're starting with two functions. We're not listing what they actually are. We don't have the definition, but imagine you do have them. With those in front of you, you can then create some new ones. By adding f and g functions together, you get function f plus g. Or you can subtract and get f minus g. Brand new function. It has some relatives in the background. Or f times g. Now remember, this is not fg. It's f times g. And also f divided by g, of course. Assuming that you don't let g be 0. That wouldn't be good, right? We don't divide by 0. So there's what the first one would look like. And this is how you would put it together. Second, if we use subtraction instead, there's your new function, the difference function. Product function, quotient function. And of course, mention again that denominator, even though it's a function, is not allowed to be 0. Now, each one of those has a domain, x's or numbers that you can use to put in those functions. So if you've got the function f plus g, for example, the x's that you use have to be usable by f, and they have to be usable by g. So the new domain is the one that allows us to use the numbers in both of those original functions. Same thing for f minus g, f times g. You have to be able to put those numbers in for both of them. Now g is going to be something we have to keep an eye on, because our function g, we cannot allow it to be 0. So sometimes we'll have to take a look at what that denominator is and maybe throw out some numbers that we really shouldn't use. We'll get back to that though. So, like I said, make sure that g is never 0. Okay? Now let's try some of these. Here we've got two functions. Here's f and g. Now why f and g? Just a reminder, those are just names. If we wanted to, we could have a function called Harry of x. But we'd get tired of writing the name Harry over and over and over. That's why we limit it to usually just one letter, f and g. And that means that if we've got f next to g, that means times. So we don't get confused. So what does this look like? Okay, This is telling us two things right away. First of all, we've got a new function. And that new function is going to get a 1 put into those original functions. And this is how we do it. Put the 1 in for function f, put the 1 in the x's for function g, and see what we end up with when we add them together. So first of all, put 1 in the first function. So we'll put 1 in f, and we get a 2. We put a 1 in for the g function. Put 1 in here, and we get an 8. That's all there is to it. Just add it together. Our function was adding together. This is getting a little bit messy, so let's clear the space here. Where's my cursor? Sorry about that. Okay, there we go. Clear this out. There we go. Okay, now you can see it again. So just add the two components, and you get the new function and the new function value. So this, remember, bring this down. This is the new function f plus g of 1. That means 1 is some number from the domain. You put it in g, you put it in f, and find out what the sum of those two function values is. Okay, we can do the same thing for a difference function. We've got the same functions to play with, so you're familiar with those from just a minute ago. All we need to do is take that -3, put in this put it into this x, also take that -3, put it in for this x, and when we get those two results, which will look like this, f of -3, g of -3, and we're going to subtract the two results. So there are two results. F of -3 gives us a 10. G of -3 gives us a -4. And the definition says subtract those. And there is f minus g of -3. Next, let's take the same ones and let's do something a little bit different. We'll take the product of those two original functions. So again, what we're going to do is we're going to take the x value we've got, we'll put it in the f, and we'll put it into the g function. And when we get those two results, we'll multiply them together. It's that easy. Yes, folks. Get those two results. Put the 5 in where the x was. Finish it up. And there is your product function at 5. And let's put this in again. F times g of 5 is 520. Got it? So you shouldn't have too much trouble with this one. We're going to take 0 and we're going to put it into f. We're going to put it in g. And we're going to see what we get. So how does this look? F over g, or f divided by g of 0. So you just take the 0, put it in the f function. There's the x squared plus 1, ends up being 1 on the top. On the bottom, put a 0 in for this x right here. 3 times 0 plus 5, and our function value is 1/5. That's it. Now, what do those functions really look like when we put them together? Well, what we can do is, since this says adding it, Let's suppose we call this one, just for fun, we'll call this h of x. That's the new name for these functions put together by addition. All you need to do is take f and g and add them together. So we'll have f is 8x minus 9, and we're going to add that, the function square root of 2x minus 1. So what's f plus g of x? We'll just combine those or simplify. And actually, it's pretty easy on this one, just because these are not similar terms, so we can't combine those. And the square root isolates that 2x minus 1. So that's really f plus g of x. How about f minus g of x? I suggest maybe you pause this. I won't mind. Pause it. You take f and g, find what f minus g of x looks like. All right, you're back. There we go. We want f minus g of x, so we'll take f of x, subtract g of x, and it looks something like this. Here's f, here's g, and we're subtracting them to get a new function. How about multiplying? Now, it might get a little bit more complicated sometimes and sometimes not. But this means times because they're put side by side or in juxtaposition, if we use a fancy word. And we'll take 8x minus 9 times, that's f, and g is square root of 2x minus 1. And that's it. Simplify if possible. Now, whoever made these slides, and it wasn't me, I've tried to fix these, but sometimes it gets to be a bit much to fix them. There should be a times there. Somehow when someone made these slides, it didn't come out the way it should have really. This is your resulting function, the product function. And of course we'll do one with division. How about you pause it? Put those things in, put the functions in, and tell me what f over g of x is. I'll just put one on the top, one on the bottom, and you're in business. Now, it says, give the domains of the functions. So here we've got part A, and let's take a look at this one first. F of x equals 8x minus 9. What's the domain? Well, there is a clever thing you can do if you remember that when you've got a regular polynomial, a polynomial, the domain is all real numbers. Or if you want interval notation, negative infinity, infinity. That's your domain. How about the other one? G of x has this square root of 2x minus 1. Is that all real numbers? Well, first of all, notice this function is not a polynomial. So, red alert, or pink alert, yellow alert, whatever, maybe the caution flag. Remember what square root means. It means you're going to take the square root of this number inside, and to take the square root, this number inside cannot be negative. It has to be non-negative. So, the 2x minus 1 we use has to be greater than or equal to 0, so we can put it in the square root function. What does that tell us about x? Well, just solve this. It's a regular inequality. We've talked about inequalities in chapter 1, I think it was. Add 1 to both sides. Remember, this still acts somewhat like a regular equation. So 2x greater than or equal to a positive 1. we want to find out what x's are, or what x's we can use. So we'll divide by 2. We're dividing by a positive, so we don't have to change the sense of this inequality. And we'll get x is greater than or equal to 1/2. Now, what does that tell us? If we put these two functions together, for x, we can use any numbers. Good. But when we put those together, we have to restrict the domain, because the x's are going to not only have to work in here, but they also have to work in there. So our resultant domain for f and g, we'll just put it that way, would be the set of all x such that x is a real number and x is greater than or equal to 1/2. There's your domain. Pick any of these x's and you can put them in for x, and you can put them in for g of x. There is one other thing that I'll mention, because when you have f of x and g of x, like any real numbers, you can add them. That's no trouble. Subtract them, anything at all, any numbers at all. Multiply any numbers, you're fine. Dividing, you've got a different story. For f over g of x, remember, we can't let this be 0. What does that mean? So, note to ourselves, for f over g, the square root of 2x minus 1, let's see what this means. How would we get a 0 there? This is a limitation. Now, to solve this, we can do something nice and simple. Square both sides, so I have 2x minus 1, 0 squared is 0, good, and 2x equals 1, x equals 1/2. So, if we're using the quotient function, we can't let x be a 1/2 either. So for this one, for the domain of f over g, we're going to throw out the 1/2, because that would make the denominator 0. So if let's see, I'm running out of room, so we'll just alter this one. For f over g, we'll have to throw out this equals, and we'll use only x's that are greater than 1/2. We can use anything for f in the numerator, that's fine. For the denominator, we can't let it to be 1/2, and to use it in the square root, we have to have something that's non-negative. So this would be the domain for the new function, f over g. Okay, I think we talked about all that. Yes, we did. So the domain, notice this is for g itself, all by itself. You include the 1/2 and anything above that. The intersections of the domains are all of these. So this is all real numbers, but you've got the intersection. So we're talking about what both of those have. And you can use the word and. The numbers that you use have to be real numbers, and they have to be from 1/2 to infinity. And we talked about this. So use those representations of functions f and g. We've already seen those. And find out what f plus g of 4 is. Find out what f minus g of negative 2 is. And f g, or f times g, of 1. And finally, f over g of 0. Here's a look at some of these. F plus g. Here's f, and here's the g function. F of 4. Now remember, we're talking about the blue line here, the blue. So we go over to 4, then up to where it intersects, and the value for f of 4 is 9. G, we'll look at the red curve. We'll go over to 4 because we're putting 4 in for x. What does 4 match up with on the curve? It matches up with a 2. So you can do it from a graph like that. And since we're talking about f plus g, you take those two results, add them together, and your function value at 4 is an 11. Now, this is where you have to be careful. F minus g, it sounds like it's going to be pretty simple, but you can't use the negative 2 in function g. Remember, g of x was the square root of 2x minus 1. You can't use a negative 2 because if you use a negative 2, you get 2 times negative 2 minus 1. You'd have the square root of negative 5. Nope, can't do that. It's not in the domain because of that. So we can take f times g of 1. So f of 1 would be there. G of 1 would be there. And those are the two values. 1 for the g, right here. 3 for the f. And this should be times. I can't fix those too easily, and it's not worth it for just a few seconds. Multiply those two results. 3 times 1, 3. G includes the origin, so f of g is 0 right here. On the red curve, 0 is used, and the y-coordinate is 0 right there. So f of g is undefined. You can't use this one for f over g. You can use it for the other combinations, but you can't use it for f over g, or f divided by g. How about these? Evaluate those for 4, negative 2, 1, 0. To evaluate those, we can look at x values, see what we get for f. So this number right here is the f of negative 2. This will be g of negative 2, but that's undefined. 0 value for x, we get a number for f, and a 0 for g, and so on. You can see those. And you can see when you can add these together. Of course, this is out. When you can subtract them, when you can multiply them, and in 2 of the 4 cases, you can divide them, as long as this doesn't end up being 0. Okay, we've talked about all that. You can review that if you like. Remember, all the slides, all the PowerPoints are in Blackboard under the content area. All you have to do is go to the proper chapter and look for the section that you want. Just one final reminder. When you see, there's my mark. When you see these, remember, it represents a times. Sometimes it represents something else. So be a little bit careful. Sometimes you'll have to use your imagination and put in here what it's actually supposed to be. All right, now we get to the difference quotient. I told you this was a little bit different, and it touches calculus just a tiny bit. We're not going to talk about how, but we're going to talk about what the difference quotient is and how you can evaluate it. Now, take a look at it. First of all, we have f of x plus h. What does that mean? That means you take the x plus h and put it in the function f everywhere you saw an x. And of course, f of x just means you're going to take the x and put it in there everywhere you see an x. In other words, you just copy f of x. It's real simple. So this is going to be something new. You're going to be subtracting the original function, and then when you have that difference simplified, you'll divide everything by h. So how does this look? We're going to use a three-step process. Find the first term in the numerator. Find this. Replace the x with an x plus h. Now what I typically do is, for this f of x plus h, I write this function f with parentheses everywhere an x was. This keeps me from making silly mistakes. So if I've got a 2x squared, I make it like this and leave a blank where the x was. And write out the rest of them. Everywhere I see an x, just leave a parentheses. Then I'll come back. I'll take this x plus h and put it into all those blanks that I left, and then simplify it. That will do it for f of x plus h. One last comment. X plus h replaces all the x's in your function. So in the case of 2x squared minus 3x, what I would do is, for my f of x plus h, I'll write 2 blank squared, there's the x with a blank, minus 3 blank. Those are blanks where the x's were. Then I'll come back and I'll say, okay, I've got some blanks, got to fill them in. With what? Well, I'm going to fill them in with x plus h. So x plus h here, x plus h here, and then all I need to do is very carefully simplify that expression. So the entire numerator, here is f of x plus h. Here is the original f of x. We're going to be subtracting those. That's step 3. Well, we're step 2. And then when we get that, and this is the tricky part, you have to remember how to square a binomial, maybe even cube a binomial. But that should be trivial stuff for you, so you might want to do some careful practicing there. So here's the numerator, simplified. And the 2x squared and the minus 2x squared are gone. Cancel each other out. You've also got a minus 3x and a positive 3x. Gone. Gone. This is the entire numerator. It looked as though it was going to be very, very complicated, and it wasn't. So that's step 2. Simplify that numerator. Next, divide by h. And notice back here that all of these terms, or all these pieces, all have h. So you can divide all 3 of them by h. So this is what you got in the numerator. You're going to divide everything by h. And remember, this means that h gets divided into all 3. You don't do something like that. Bad idea. Instead, you make this 4xh over h. Here's the plus, so you put a plus in here. 2h squared, that gets divided by h. Each term in the numerator gets divided by h. Minus 3h over h. You're going to be able to cancel out the h's properly, or factor it out, same difference. And there is our difference quotient. One final caution. These are not the same. You have to do what I said. For this, replace each x with x plus h. You can't split them up like this. Okay, now we're going to get something a little bit more exotic. Not terribly complicated usually. This is called the composition of functions. Now we're not going to belabor the domain part, but remember, for the domain, you have to be talking about numbers that will work for f and will work for g, and any combination. So for this one, the way this works is, remember the x represents a number. If you want to find f of g of x, you'll take the x, put it in the g function, find out what you get. When you get that result, put it in the f function for the x's. And your final result is f of g of x. And this is another way of describing the same thing. But it's a little bit better in a way, because this is probably is something that you can relate to just a little bit better, although you can get used to this f of g or composition notation. This says, remember, you start inside any parentheses, so you'd have to find g of x first. Take that, put it into the x's in f, and evaluate or simplify, and there's your answer. So how does this work? Remember, f of g of 2, we could write a different way. We could say f of, we've got to do the g part first. So we've got to find g of 2. When we find this, then we'll put that into f. So what's that look like? What's g of 2? Well, here is g. We're going to put 2 in for the x. So g is 4 over 2 minus 1. And here's the 2 we're sending to g. And the answer will be sent to x's in the f function. Well, we've got to figure out what this is first. We're taking f of what? We have 4 over 1, which is 4. Pretty simple. Now we'll go to the f function. The f function is here. So what we'll have is 2 times, we're putting the 4 in where the x is. There's the f function with the x replaced by a 4. And what do we get? We get a 7. So f of g, composed with g, of 2 is a 7 when all is finished. So get the g of 2 because that's the inside function. And when you've got that, put that 4 in the f function, which is there. There's the 4, and there's your 7. Now take a look at this. Look familiar? Well, it should. This looks like it's the same thing we just did. What we just did was f composed with g of x. Well, this just is the reverse. Isn't that the same thing? Let's find out. Now, this means that we're going to give the -3 to f first, get the result, and send it to the g function. So, maybe you would prefer to write it like this. It's up to you. So what happens when we take the -3 and put it in the f function? What do we get? Put the -3 in here. So we'll put everything here. The f is 2 times x minus 1. And the x we're using is -3, so we'll put a -3 in here. What does that give us? G of -6 minus 1, -7. Are we finished? No, not really. We've got -7. We have to feed that to the g function. How does the g function work? The g function works like this. 4 over something minus 1. What's that something? The -7. Put the -7 there. What do we get? 4 over -8 or -1/2. Make sure that negative shows up. So this is -1/2. There we go. Next, we're going to use some different functions this time. We'll sort of worn those out. So find each of these. So how do you do that? Remember, g is the inside function because it's closest to the x. So x is going to be fed to the g, and then that to the f. But we don't have any number. How does this work? Well, first of all, perhaps you'd like to do this. Now, what is g of x? Well, we don't have any number to put in here yet, so we'll just leave it as x. So this will be f of, and what is f going to get? It's going to get the result of 4x plus 2. Okay? Now what? Well, this becomes the new x for f. Well, what does f look like? F does this. And what goes in for x? This goes in for x. 4x plus 2. And that is it. Remember, take that x, put it in the inside function first, and then feed whatever you get to the outside function, or the next most outer function. Because you could have 3 in a row, but you probably won't see any of those here. Okay, so how about the domain? Well, this is a polynomial, so it's got a domain of all real numbers. This one, not, because this has to be non-negative. X has to be greater than or equal to 0 here. But what does F really see? F really sees the 4x plus 2 that comes from G. So this really, when F gets it, it's already received 4x plus 2, and that has to be greater than or equal to 0. So solve that. Subtract 2 from both sides. Divide by 4. Now we're dividing by a positive 4, so this stays greater than or equal to negative 2 over 4, or x is greater than or equal to negative 1/2, which is what they got here. So the domain is negative 1/2. Remember, that's included. So you have the bracket and everything larger than that as well. How about the other way around? Remember, f is the inside function on this one. So first of all, f is going to have only non-negative numbers. And when we get to g, it'll take anything, any real number. So g gets what it got from f, which was the inside function. This is what g looks like, and this is what g received from the f function. Simplify just a slight bit, and there you go. So the domain of this one is all real numbers. This one is non-negatives. So the combination of those is 0 to infinity. Okay, how about these? F of g of x, or f composes g of x. G is the inside function, so that's what f is going to get. So f of g of x is another way of writing it. Now, what does f look like? F looks like this. 6 over x, so leave it blank, minus 3. That's f. What is f going to see? F is going to see the result of this. So that's what we put in for x. 1 over x. This is f. That's g coming into f. And then we simplify. So we've got 6 over, get rid of that, 1 over x minus 3. The simplest way of doing this is you've got a fraction here. That makes this whole thing a complex fraction. The easiest way is by multiplying x over x. What's that going to do? Well, on the top you get 6x. That looks pretty good. That's a polynomial. And on the bottom, remember, you multiply the x times both of these terms. So x times 1 over x, 1. X times minus 3, minus 3x. And there you've got f composed with g of x. If you want to, you could also write this. If you multiply both top and bottom by negative 1, maybe some of you are a little bit obsessive and don't like this minus 3x on the bottom. It's up to you. You could write it this way. Now, the main reason I mention that is if you happen to get this answer yourself and you look in the back of the book and you find the answer looks like this, that's why. So this is g of x. Oops, did I do that right? G. Yeah, okay. And looks looks as though they stuck with the first one. How about its domain? All real numbers except 0. X can't be 0. And if you look at this one, the denominator can't be 0. So x also can't be a 3. So we have to throw those out. What's the domain look like? Well, remember, you've got the real number line like this. You might draw a picture first. There's 0. I'm just going to make this real easy. There's 0 and 3. We'll throw in a -3 here. Now, what's it look like? Well, we're throwing out that. That's empty. We're throwing out this. So it's everything else. We've got 3 sections here on the number line. And we need to include all of those, so we'll need the union, the set union. So first of all, this section right here is -infinity to 0. And we'll have the union with this section in here, which is 0 to 3. Union, sorry, I'm going to, and this section right here is 3 to infinity. Okay, so that's the domain for this combination function. Oops. Okay. My mistake. I stand corrected. Okay, how about this one? Not too much to go. Okay. Remember, this is f is the inside function, g is the outside function. So take this f and put it in the g function. F is this, and it's going to go in here where the x is. So we'll have this, and can't use a 3 because that would make this denominator 0. Other than that, everything's fine. You can simplify by multiplying top and bottom by x minus 3. Sort of like this. X minus 3 on the top, and the x minus 3 on the bottom. They'll cancel with this one, and we'll have the x minus 3 on the top, and the 6 over 1, or 6 on the bottom. So we can't use 0, and we can't use the 3. And we're getting close to the end here finally. So what do we have here? We've got g of f of x, also written g of f of x. And this is f of g of x. In other words, we're composing those functions to a more complex one, but in an opposite order. So, are they the same? That would be handy, right? Because 6 times 8 equals 8 times 6. That's nice. Can we do it with functions? First, we'll find this one. Since it's on the left anyway, we'll go with that one first. We have g of 4x plus 1. It gets a little bit more complicated because this, remember, this is the g. So we're going to take those x's and replace them by 4x plus 1's there. 2x squared plus 5x. Simplify using the distributive property. Make sure you square this binomial properly. Remember, it'll be this squared, and double the product. This squared is 16x squared, and this squared is 1, and 4x times 1 doubled is the 8x. And using the distributive property, we've got that, and there is our combination after we've added the like terms. So 32x squared plus 36x plus 7. Remember, that's g of f of x. F on the inside, g on the outside. Now, how about the other way? Now we'll go the other way. We just looked at this one. We're going to look at it the other way. So g of x will be the inside function. This will be the inside function. So this will go into the x in the f function. We're putting that in where the f has x's. This is what was x in f before. Now all we need to do is simplify. Use the distributive property, and there we go. Now, is that the same thing as the other one? No. Now, you'll be asked occasionally, not too often, fortunately, how you actually create these. Ask yourself, what's the inside function? What's the outside function? So, in this case, the inside function is this, and the outside function is these replaced by x's. So the inside function is g of x is x squared minus 5. That goes here and here. And the outside function, what's that? We'll go back to here, replace all those inside functions with just x. What's that? Well, x cubed minus 4x plus 3. And there are other ones that will work, but that would be the main one that you would expect to find. Well, that's it, folks. We have made it through Chapter 2. Give yourself a high five. I guess that'd be fair, right? We'll see you next time in Chapter 3. Get ready for that test, though. Remember, I'll give you a practice one. Make sure you practice with that and bring any questions to class. I'll see you soon. Bye-bye.